Hello and welcome. Today we're going to be doing dot product calculations and study the property of orthogonality. Let's start with this. So this particular problem would be a good exam problem. It doesn't involve vectors with specific numerical components, but rather the following. Let's say we're given u, v, and w, three vectors, such that the following is true. U dot v is equal to 1. U dot w is equal to 5. And v dot w is equal to 3. Furthermore, u dot u is equal to 3, v dot v is equal to 9, and w dot w is equal to 11. Okay, so without knowing anything about the vectors, all we know are these dot products. Let's see if we can do the following. So we have three questions. We're going to have a part A. And the part A is find a number A such that I can't spell such that A times U plus V is orthogonal to W. Okay, B, for any A value, find an expression for A times U plus V in magnitude. We're going to do magnitude squared. Okay? All right, good. Okay, and then C, find a value A such that the magnitude of that vector is minimum. Okay, so let's see if we can answer this question. So there's the question. There's the three questions we want to have. Let's give an answer to A. Okay, so orthogonality means that A times U plus V dotted with W is equal to 0. So we're going to use linearity to write it as this. A times U dotted with W is plus V dotted with W is equal to 0. I can rewrite this as A times, and then U dot W is given by 5, plus V dot W is given by 3. I set that equal to 0. That then implies that A has to equal negative 3/5. Right, so there's the answer to our first problem. Okay, so now let's get an answer to our second problem. We have to know this. If I have a vector H, and I look at its squared magnitude, that's the same thing as H dot H. That's true for any vector. So, AU plus V, I'm going to dot it with AU plus V. And that's the same thing as the squared magnitude of AU plus V. All right, so now we have to use the dot product that it works, it has a distributive law. So of course we have to distribute in all those dot products, and we're going to get a squared u dotted with u plus 2 times u dotted with v times a plus v dotted with v. And then we look up to our table of values for all those dot products, and they're there. So we get 3a squared plus 2a plus 9. All right, so that's this right there represents that magnitude. And now C is find a minimum magnitude for this problem. All right, so we know it's equal to 3a squared plus 2a plus 9. Right, so this is, so in terms of a, that's a upward facing parabola. So what I'm going to do is actually take the derivative with respect to a. And that's going to be 6a to the first power plus 2. And then I set it equal to 0. And of course, I'll get from that a is equal to negative 1/3. To understand if that is a minimum or a maximum, all we have to do is look at the second derivative and find out we get 6. Of course, that is greater than 0, so this truly is a minimum. All right, so that answers all of our questions about how to use the dot product, use the property of linearity, the distributive law, how it passes through scalar multiplications. All of those things are important when we're using dot products, so this is a good problem to just go over all of those skills. And of course, how to relate the magnitude with the dot product. I think that's also a very important identity to have in your front pocket. And of course, that distributive law, like we talked about. Okay, so I hope this video helps you just to give you some practice with dot products. Thank you very much.